9, we had to supply the missing reasons here, fill in the blanks. Given A is parallel to B and C is parallel to D, they want us to prove 1 and 3 are congruent. So looking at the picture, given A parallel to B, they're telling us that angle 3 and 2 are supplementary. 3 and 2. Why would they say they're supplementary? Can you classify them as one of our 5 angles from yesterday? Spence? Good, and this theorem says that if the lines are parallel, then same side interior angles are supplementary. This is your reason for number 2. They're supplementary because the lines are parallel. So if lines parallel, same side interior angles are supplementary. And then the book, for some reason, splits up their given. I usually put it all in the first step, but now they're going to tell us that C is parallel to D. So those are the vertical more lines. And then it says that 1 and 2 are supplementary. Same thing, because A is their transversal, so they're on the same side of the transversal in between the 2 lines. If the lines are parallel, then same side interior angles are supplementary. So if we look at our statements here, 3 and 2 are supplementary and 1 and 2 are supplementary. What does it mean when angles are supplementary? They add up to 180, right? Let's pretend that angle 2 is 100 degrees. What would 3 have to be? 2 is still 100 degrees. It's the same angle, so what would 1 have to be? 80. There's a theorem from chapter 2. If 2 angles, 1 and 3, are supplementary to the same angle, then those 2 angles are congruent. So your reason for number 5 is that theorem, which is called the congruent supplements theorem. 2 angles supplementary to the same angle are going to be congruent. You wouldn't want to put substitution in this step because the substitution property states that 2 values have to be equal, then you can substitute it in. Well, if you look at your steps 1 through 4, we never stated anything being equal to each other, so I can't substitute it in. It'd have to say like x equals this, then substitute it in. You all right? Okay. Because I'm sure you never got them with any of your sneezes before. Oh, okay. All right. Are we good on 9? Micah, quit trying to be a little, I don't know what. Micah, don't throw erasers at people. Number 10. We're using the same given information from number 1. So, or excuse me, from number 9. A is parallel to B. C is parallel to D. Given. This time they want us to prove that 1 is congruent to 3 without using angle 2. So I'm just going to cross it off. So now we're using 1, 3, and 4. Okay. So since we're trying to prove something about angle 1, we'll look at angle 1. Do you know anything about 1 and 4 or 1 and 3? Good. 1 and 4 are alternate interior. That means they're congruent. So let's write that down. Angle 1 is congruent to angle 4. Reason. Good. Alternate interior angles are congruent. Awesome. So we have 1 in the proof, but we're trying to prove something about angle 3. So then you got to look at angle 3. Micah, is your hand raised? What do you got? Why? Good. 3 and 4 are corresponding angles. They're both above the transversal B and then to the left of the 2 parallel lines. So on step 3, we can say angle 3 is congruent to angle 4. If lines are parallel, corresponding angles are congruent. Well, if 1 is congruent to 4 and 4 is congruent to 3, what can you say about 1 and 3? They'd have to be congruent. What's our reason for it, though? Good. Since 1 is congruent to 4, we can substitute 1 in for 4, and we get 1 congruent to 3. We're good with 10? Mm-hmm. All right, to 28 then. Okay, 28. Given A is parallel to B and 1 is congruent to 4, we're going to prove that 2 and 3 are congruent. So A parallel to B, comma, angle 1 is congruent to angle 4. Given. Okay. There are 4 lines here. You have to be careful. Only A and B are parallel. So then I have 2 transversals. I have, I don't know, we can call this transversal C and this one transversal D. If I look at transversal C, then I'm looking at angle 1 and 2. What do you know about 1 and 2? Same side interior, and since these lines are parallel, then those same side interior angles are going to be what? What is it? Same sides are supplementary. Yep. Bless you. How should we write this? Okay, what do you want me to put on the left side, though? Just like that? I like how when you were reading your reason, you added your L and you went supple. Is that how you abbreviate it with an L? I like that. I like it. Good. 1 and 2 have to be supplementary because if lines are parallel, then same side interior angles are supplementary. So we have 2 in our proof. Angle 3. Well, angle 3 uses transversal D. So what can I say about 3 and 4 since they both touch transversal D? Same thing, right? They're supplementary because they're same side interior. Since it's the same thing, we can put it in the same step. So just put a comma after your supplementary and write angle 3 and angle 4 are supplementary. It's the same reason that if the lines are parallel, same side interior angles are supplementary. Okay? So what do we want to do now? Micah, you have an idea? 2 and 3? Where? Where? I'm confused. Megan? Okay, so since 1 is congruent to 4, then I can substitute one of these values, right? Because they're equal. So Micah, what do you want me to substitute? Okay, what can I substitute? If 1 is congruent to 4, where can I substitute 4? For 1, right? Right here. So then this statement would say angle 4 and angle 2 are supplementary. Is that what you said? Okay. So look at the statement we just created and the statement from step 2. 3 and 4 are supplementary. 2 and 4 are supplementary. We have 2 angles, 2 and 3, supplementary to the same angle. What can you say about those 2 angles then? 2 angles supplementary to the same angle must be what? Congruent. Because think of it like on that number 9. If angle 4 is 100 degrees, then 3 has to be 80. Well, if angle 4 is 100, then 2 has to be 80. So they're congruent. So step 4, angle 3 is congruent to angle 2 and we're using that congruent supplements theorem. Two angles supplementary to the same angle are congruent. That's not the only way to prove it. You could have proved it differently. Instead of saying like angle 1 and 2 are supplementary, you could have wrote an equation, the measure of 1 plus the measure of 2 equals 180, and proved it going that direction. Is that what you did? And then you erased it all? Sorry. All right, we're good on 28? To 29. 29 says prove theorem 3-2. So that means you have to do it in more than 2 steps. You can't use the theorem to prove it. We are given that A is parallel to B, and we're trying to prove that 1 and 2 are supplementary. So I understand that when I look at it, 1 and 2 are same side interior angles, so they should be supplementary according to the theorem, but that's what we're trying to prove. So we want to prove it differently than using this theorem. So instead of connecting angle 1 and 2 right away, connect angle 1 to angle 3 maybe. What's the relationship, Trevor? Corresponding. And since the lines are parallel, then corresponding angles are going to be congruent. So we can say angle 1 is congruent to angle 3. If lines are parallel, corresponding angles are congruent. Good. We have 1 in the proof now. Now we need to get angle 2 somewhere in the statements. Why? Awesome. Measure of angle 2 plus the measure of angle 3 equals 180. And that would be by your angle addition postulate. Two angles that make a line have to add up to 180. That's good, because now we have some angles being supplementary here, but we want 1 and 2 to be supplementary, and this is telling us 2 and 3 are. Micah? How did you do that, though? Good. Since 3 or 1 are congruent, I can what 1 in for 3? Substitute, right. So number 4, the measure of angle 2 plus the measure of angle 1 equals 180. Oh, is that our 3.5 step? And remember, the last step in your proof, the last statement, should match what you're trying to prove here. So we're almost there. Since they add up to 180, would we call them supplementary? All right, so you can just write that down. Angle 1, angle 2 are supplementary, and that would be by the definition of supplementary angles. Two angles that add up to 180. And then we have uno más. Number 41, the book said not to prove it, but I wanted you to prove it. So you're given for 41, should have been L is parallel to M, N is parallel to P. Given. And we're trying to prove that angle 1 is congruent to angle 5. Anybody got any suggestions or thoughts or ideas? Spencer? I will accept that, yep. Oh, Micah? I can put in the same thing then, couldn't I? No. So we've got 1 congruent to 7 and 3 congruent to 5. And I'm trying to prove that 1 is congruent to 5. So I got to find a bridge to connect all these angles together. Micah. Good. Angle 3 is congruent to angle 7, because if your lines are parallel, alternate interior angles are congruent. So 1 is congruent to 7 because they're vertical. 7 is congruent to 3 because they're alternate interior angles. And then 3 is congruent to 5 because they're vertical angles. So would 1 and 5 be congruent? What would be our reasoning for that? Substitution. Or transitive. Anybody do it differently? No? Nobody started anywhere else? No one said like 1 and 3 are corresponding and then jumped? You did? Why didn't you say that? No, it's not even use corresponding angles. It pretty much is, but you're right. Did anyone do this? You did, Sam? You're such a liar. You could have done that in 2 steps. Because angle 1 is an alternate exterior angle to 5. And if your lines are parallel, alternate exterior angles are congruent. So, done. No, it's outside of your parallel line. So if I'm looking at angle 1 and 5, which one is the transversal? Which line hits both these angles? Is it L, M, N? N. This would be your transversal. And then L and M are the parallel lines. So when you look at them in relation to the yellow lines, 1 and 5 are both on the outsides of the yellow lines. Does that make sense? Because I'm looking at the vertical ones, not the horizontal ones. Okay. There we go on today's homework then? Okay. Hang on.